So what have we covered so far? We all understand something about trigonometry, correct? And understand it very well, in fact. So what is it that we measure when we ask for sine of theta? It's simply that we have this, right, for any angle. Here is that angle, the crust of the pizza. The crust of the pizza is measured in radius units. So that means that if I make the pizza smaller or larger, then everything is increased proportionately, right? So what's important about triangles is their proportionality. Yes? So when I ask for sine, I'm actually just asking to measure, where is it? Yes, similar triangles. And so when I ask for sine, I'm asking for the measurement of this red line in radius units. So I measure the angle in radius units, and I measure the line segment in radius units, and that's very convenient. For those that stayed in office hours, I spoke about this picture. I drew only sine, cosine, and tangent. But in this picture, you should be able to see every other trig function. You should be able to see cotangent, you should be able to see secant, and everything else of the sort. Good? And if not, guys, again, don't hesitate, we'll talk about it. Today, after class, if you are interested, I mentioned artillery, right? So we can actually see if you could make it into artillery regiment. They used to be, of course, very good in mathematics. They had to be, because on the spot, very fast, under fire, you have to aim your cannon and destroy the target. Everybody who was an artillery commander had to be good in mathematics. I assume it might still be true today, but maybe. Or trebuchet, yes, but trebuchet, yeah, that's true. But trebuchet that works on slightly different principle than a cannon. Right, so that's true. Again, slightly different principle, but yeah, all of those things, especially for cannon, especially for firearms, that trigonometry becomes very handy. And if you stay after class, I will show you how it's handy. We will do a calculation. I did it with my morning students. Yes, and we can do that with a song, right? If you want, we'll have it. We'll have a song. We'll send you to war. There will be massive casualties because you do not know how to solve it fast. But some of you will destroy the enemy. We will prevail. I am certain. So stay after class. We will learn to shoot artillery. And that's a good test for trigonometry. You will need all of your trigonometric skills to destroy the enemy. So I did mention everything about sine and cosine. You remember that sine of theta and sine of minus theta have different signs, right? So sine of minus theta is minus sine of theta because rotate counterclockwise, rotate symmetrically clockwise, and you have, yes, and you have that the same vertical segment is drawn, except that one is below the x-axis and the other one is above the x-axis. There is symmetry. If you rotate by theta and minus theta, there is symmetry with respect to the x-axis. Yes, you can actually think about, can you describe symmetry about the y-axis? Let's do it later, okay? But here is a simple question. Can you use angles to describe symmetry about the y-axis? If this is an angle theta, what would be the angle to make it symmetric about the y-axis? All right, and then we did this, right? Very important aspect that, again, I will emphasize it one more time. Let's see if you remember, guys. If I assign x the value -4, and let's say I assign r the value 5, will you please help me and tell me what is sine of this angle theta? So let's begin with this, actually. Tell me what is cosine of the angle theta, quickly, from this assignment. If x is -4 and r is equal to 5, please tell me what is, and be careful, guys, be very careful. What is And remember, very importantly, guys, very importantly, what's the maximum and minimum values that sine and cosine can take? Because I see some people writing something and not what they're writing isn't quite right. So I received 3 responses and none of them are correct. Why are they not correct? Okay. 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 So I asked for cosine and then for sine, guys. Right. So what is cosine of theta? James, you're almost one small tiny mistake in what you wrote. Alan, I'm asking for cosine right now. Right, let's see cosine, and even if it's your answer for sine, it's not exactly correct. Okay, guys, come on. You should know better. That's why we are, again, if you have questions, why is the first exam so slow to come? That's why, because you see, theoretically, this is all common knowledge or something you know before this class, but practically, I don't see that people understand trigonometry. Carolina, beautiful, bullseye. Alan, bullseye. Alisa, bullseye. By the way, Alisa, welcome back. I hope you're feeling better. Come on. How are you going to survive the artillery barrage? Heidi, wonderful. Yes. Yes. Bullseye. Yeah. Should I speak in German? No, right? Yeah, you don't like it. Wir brauchen Artillerieunterstützung. We need artillery reinforcement. That's what we're going to do after class. So stay. Make sure that you are able to carry it out. So the answer is, in fact, -4 divided by 5. Now, cosine can never exceed the value 1. Neither can sine exceed the value 1 or go below the value -1. Now, why did I convert it? So some people say just the x-axis. You are correct, except for one small, tiny, and important thing here, right? Here, when I say that r is 5 and x is -4, I am clearly not measuring in radius units. You understand? So the ruler where I drew my circle is not in radius units. So when I ask for cosine, I'm asking for the horizontal side measured in radius units. So when I say -4/5 or -0.8, it means that that the horizontal leg of this triangle lies on the negative x-axis and is 80% of the radius length. You understand? 0.8 or 4/5. This means 80% of the length of the radius, 80% the length of the hypotenuse, or simply 0.8 radians. Does it make sense, guys? So you communicate by proportion. So why is that so? That means you just divide by 5 because -4 units per 5 divided by 5 is per radius. How many units on the x-axis per radius? Now, what about, so you can remember it as, of course, simply as adjacent over hypotenuse. But think about it. What are you trying to communicate? Adjacent over hypotenuse, you're communicating proportion. How much is this side compared to the length of the radius, to the hypotenuse? That's really why you define it as adjacent over hypotenuse. You need this similarity. What about sine of theta, please? And quickly, guys, we want to move on. This is still pre-calculus review. Good. Oh, 6 messages. Wonderful. Let's see. Hopefully, but I want you to tell me what's y, my friends, right? What is y? What is y equal to? I gave you x, I gave you r. Give me numbers. Yes, Heidi. Yes, Alan. Numbers. Good. It's a right triangle. We remember it's a right triangle essentially of length 4 and radius 5. So the remaining side easily obtained, right? Oh, hello, Rachel. The remaining side is simply minus square root of 25 minus 16, which is 3. It's minus because the y is on the negative y-axis. So the answer is minus 3 over 5. So the altitude is 60% of the radius. You understand? That's what I'm saying. The altitude of this triangle is 60% of the radius. And the altitude can never be longer than the radius. That's why sine cannot exceed r. You understand? So it cannot exceed 1. You understand? So when you say sine and you give me a number bigger than 1 or smaller than -1, you are making a mistake in communication. Everybody understands? I kind of imagine, oh, I'm making this all clear, but maybe you have an entirely different opinion. I'm hoping that I'm not making things difficult unnecessarily. So at least, right? But it's hard to say truly. I sometimes have that feeling. I was reading this book about quantum mechanics, and I think, my God, this the way they are writing their brackets and whatnot, they are making it unnecessarily difficult, because physicists, they have a different symbols for mathematics, and you wonder, how do they express things? It's somewhat not the way I like it expressed. But if you are interested, we'll talk about that as well. So.
Wait, I'm confused. I'm sorry.
Yes, so go. Here. Well, yes, let's say.
So, how I got, because I know that you know, a plus b equals c squared, right?
A squared plus b squared is c squared.
Yeah. So why is it? Because what I did was, right, I knew that c squared is the c squared is r, right, because it's the hypotenuse. So I put 16 plus y equals 25. Down minus 16 for both sides, right? And then I'm supposed to get 2y equal. I mean,
here, just a second. So here you said everything right, as if I heard correctly. You said that you said this. You said y squared equal to 25 minus 16. Am I right so far? 25 because r was 5. So r squared is 25 and x was -4.
Yes.
We're just only measuring sides. I mean, where it's located afterwards, we can add the minus, right? So y squared is 25.
Never mind. Never mind. You got it. Never mind. It was
good.
Yeah,
Good.
You're right.
Wonderful. So now makes sense. Yes, everything good.
Yep.
Great. In German, you say it klar und deutlich. Clear and deutlich, like pointing in one direction.
Okay.
Good. You can learn German as well. You say it klar und deutlich.
Klar und deutlich.
Klar und deutlich.
Klar und deutlich. Klar und deutlich. It sounds weird. All right.
Good. Yeah. Weird in German is seltsam.
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 Good. Anyhow, so sorry, I'm itching to teach you other things as well. So where are we now? Oh yeah, now we know, remember that, guys, right? Cosine squared plus sine squared equal to 1. That's nothing else but re-expressing Pythagoras identity. It's like saying the horizontal squared plus vertical squared equals to the hypotenuse. I just normalized it, right? So I just measure the triangle here. You understand? Because not the numbers matter, but really the geometry. The square constructed from x, the square constructed from y equals to the square constructed here on the hypotenuse, if you sum the squares. Yes. So that is pretty clear. Agreed? So because cosine, if I measure in unit radius, cosine is the horizontal leg, sine is the vertical leg. Squaring them and adding gives you the square of the hypotenuse, which is 1. From there, I can divide everything by cosine squared, and I get 1 plus sine squared over cosine squared, 1 over cosine squared, or secant squared. Yes, so 1 plus tangent squared is secant squared is just the same thing here. 1 plus tangent squared is secant squared. You can also see that in this triangle, guys. Where do you see 1? You see, I extended this. This is the 1. 1 squared plus tangent squared. This is secant. This line is secant if you haven't noticed. Here. Secant theta, not x, apologies. Yeah, good. So here is where you see it. 1 squared plus tangent squared is secant squared. So that is an identity that you can see by the picture, and that's an identity that you can just obviously see from this calculation. Good. So just before I continue, guys, everything clear? Thus far, everything absolutely clear, yes? Or as you say, klar und deutlich.
I just want to confirm one thing. When you, sorry, when you go up a little bit up.
More?
Page,
Do you mean to the first diagram?
It was where you were showing that cosine squared plus sine squared equals to 1.
Yes.
We say 1 because that's actually r squared, right? And it's a unit circle.
Squared,
that's
right?
how you got
You change the measurements, and as far as you know, this is 1 leg squared plus another leg squared equals to the hypotenuse squared. Hypotenuse happens to be 1. It's just a statement about relationships between sides and hypotenuse of a right triangle. And in this picture, as you can see, the bigger triangle, it's 1 squared. This leg is now 1 squared plus tangent squared equals to secant squared, right? Because the hypotenuse is secant. If you don't see that, guys, I do encourage you to stay after class. I spoke about it in with other students. Good. So trigonometry, if understood properly, it's very easy. Of course, up to a point. So then we have, again, we have this identity, and we also have cotangent squared plus 1 equals to cosecant squared. Good. That's if I divide this identity by sine squared everywhere. I get cotangent squared plus 1 equals to cosecant squared. It's really just re-expressing same identity. Then we spoke about, remember, there are only very few angles for which it's easy to calculate trig. For pi over 4, that's one of them. And why is it easy? Because what you can do is you can take a square of sides 1, cut it in half, you get the pi over 4 angle here, and then you can read off what sine of pi over 4. It's opposite divided by hypotenuse. You understand why you divide by hypotenuse? Because you scale it down to be where the hypotenuse is radius, is 1 unit length, right? And you measure the length here in radians. You see, if the hypotenuse is √2, that means that this length is not measured in radians. Right? That's why you divide by √2. You convert to a different measurement. Clear? And the cosine of pi over 4 is 1 over √2. So it's √2 over 2. Good. And
wait, why do we divide by √2?
Sorry?
Why do we divide by √2?
Because you see, so there is a, imagine that you can draw here a circle, right? You can draw here a circle. Here is that circle. Yeah, that's part of the circle. Now, what's the radius of that's the center of the circle. The hypotenuse always makes the radius of the circle that you draw in trigonometry. Good. Now, is this a unit circle? No, it's not a unit circle because its radius is not 1 unit length, it's √2 units length. Now, there is this thing, guys, that you might think this is a unit circle, this is not a unit circle. There is no such thing as a unit circle or a non-unit circle. All it means is that you use different measurements, right? So maybe this is 1 inch long, but not 1 centimeter long, you understand? Or not 1 meter long. It's only conversion of measurements. Really, what is the statement when you say this is 1 radius long? You're saying that here, because I see that radius is not represented as 1 unit, it means that my markings, the ruler on the y and the x axis, are not in unit of radius, right? It's a different unit. So how do I so when I measure sine or cosine, I'm measuring this length. For sine, I'm measuring the length opposite to this angle, this length here, and I measure it in unit radius. So how do I convert? I measure it in my current units. It measures 1 in the current units, and I divide it by √2 to measure it in radius units. You understand? Does the explanation make sense, Pavel? Yes, guys, you understand why you divide? It's a very simple thing, right? If you imagine that, well, you have 2 units, right? So that's very simple like this, right? So imagine, I'm just going to make it very simple, right? Imagine that this is your units, and we have this length, right? So if this is my radius, right? The radius is this full thing. It's 2 units. What is this? This is in radius units, this is 1/2. Right? It's half of a radius. You just take how many radii does it contain? It contains one segment divided by the length of the radius 2. That converts the measurement into radius units. I hope you understand. All right, so you understood how I obtained this quantity 1/√2. I used Pythagorean theorem, which I proved to you. It's a very simple proof. Don't, by the way, assume that you know something. Always close the book and write it. You might have become familiar with the topic and not realize that you don't understand it. You understand it if you can produce out of yourself, without too much effort, produce those arguments that I'm presenting. You know, that's how you train. You close it, you write it down, and you think, oh, do I remember everything correctly? You try to narrate the story or teach it to somebody. It's also a great idea. All right, let's do this, guys. 5 pi over 4. I want you to calculate what is cosine of 5 pi over 4, please. So tell me, what is cosine of 5 pi over 4, please? Okay, good. So all you have to do is figure out where that where that thing is, and then it's easy to calculate. Let me actually erase it from here, and let's do it. Let's do it properly. Here. So I want you to calculate quickly cosine of 5 pi over 4. Come on, guys, as quickly as you can. Lisa, today you're not showing yourself, I see. Wonderful. I have 2 people. No worries. I'm just glad to see you when I can. Come on, guys. Fast. We have to cover so much today. Makes me nervous about how much material you have to learn on your own if I don't cover it all. You understand, guys? That's what you call not a step backwards. You learn everything. All right. Beweg euch. That's how you say in German. Move faster. Good, James, wonderful. But I still only see, well, let's say how much? 1, 2, 3 people. 4. Okay, come on, faster. Faster. Yeah, so here is how we solve it, guys. Very simple idea, right? So what is 5 pi over 4? This is how I think of it, right? 5 pi over 4 means that it's 4 pi over 4 plus pi over 4. 4 pi over 4, it's pi. So it means that I went around half the circle, and then I moved, I'm in the 3rd quadrant. I'm in the 3rd quadrant, right? So I already know the value. So it's pi over 4 in the third quadrant. And so it's like power. This side is negative, and cosine and sine are both negative. So cosine of 5 pi over 4, it's minus 1 over radical 2. Or if you prefer to normalize it, you can say you may make the denominator radical 3 minus root 2 divided by 2. Good? You understand that it's just that square cut in half, as I did before. Back to this. Again, guys, if it's too fast, you can stay in office hours. We can practice solving those angles. You have to be good at it. Here is the other triangle that you need to understand how it's made. You could have come up with this idea on your own. So here is an equilateral triangle, right? So equilateral triangle, each leg is the same. So I can fold it in the middle. And if I fold it in the middle, I see that those two angles are the same. So this angle and that angle are the same. I didn't draw it too well, but really I can also fold it along this vertex. And then I see that this angle and that angle are the same. So all the angles must be the same, agreed? Every single angle is like every other angle, and we know they add up to pi. So that means, you remember how I proved that it adds to pi. I wonder how many of you remember it. So so that means that 3 times the angle theta equals to pi, which means the angle theta equal to pi over 3. That's how I know. And each of them is pi over 3. Good? So then what? Then since I cut it in half, I know that this is 1/2 and this is pi over 6. So I have now this triangle where one side is 1/2, vertical side is not known, and hypotenuse is 1. So what I can do is I can take 1 squared minus 1/2 squared. That will be 3 over 4, sorry. And then I take the square root, it's root 3 over 2. You all understand how I got root 3 over 2? It's just 1 squared minus 1/2 squared, and I take the square root. Please confirm that you understood, right? Why or something. You don't need to type too much. I just want to be sure that this is extremely obvious to you. We will check in a moment your comprehension. Beautiful, right? So then it's very easy to calculate lots of angles, correct? Very easy to calculate lots of angles. For example, what would be sine of pi over 6 from this picture? Sine of pi over 6. Pi over 6. Come on, guys, it's in the picture. Exactly, Rafid, beautiful. Wonderful, James. Yes, come on, only 3 people. What about the rest of you? It's right in the picture. Good, Carolina, good, Pavel, good, Alisa, good, good. I don't see everyone still. 30 people, guys. Faster. Faster. I just today I feel a little sadistic, so don't I always? So 1/2, yes. Good. Now, how do you see it? You see, guys, why is it opposite? If I were to position the triangle in the correct form, then you would see that the opposite, the vertical side would have been 1/2. Just turn the picture upside, rotate the picture 90 degrees and you see it, right? It's opposite over hypotenuse. In this case, I don't really need to divide by hypotenuse. It's measured in unit radius, yes? So it's just opposite. What is tangent of pi over 6? Tangent of pi over 6. Tangent of pi over 6 is 1/2. Tangent of pi over 6 is 1/2. Was sagt ihr, Kinder? Wonderful. Or yeah, so what is the tangent of pi over 6? Careful, look at it. Pi over 6, I said. Careful, guys. Pi over 6 is what? I think I said wonderful to some people, but not exactly. Not exactly. Tangent of pi over 6. Opposite is 1/2. Adjacent is √3. So what is that? This is 1/2 divided by √3 over 2. Or if you notice, simply multiply by 2 top and bottom, you get 1 over radical 3. 1 over radical 3. You can see it over here. Good? And the like. You see, so once if you can establish this triangle, you can easily see all possible proportions for both pi over 3 and for pi over 6. Good. And then in other quadrants, I'm going to skip it. We can do it after class, right? We have all those different angles for which it's really like pi over 3 or pi over 6, but in a different quadrant. Make sense? So that's pretty easy. How do you think of it? It's a 4 pi over 3. It means that you overshoot pi. So 3 pi over 3 and then go another pi over 3. So it's pi over 3 in the third quadrant. 4 pi over 3 is pi over 3 in the third quadrant, right? As soon as you know the angle and you know in which quadrant, it's very easy to calculate the trig signs. The quadrant determines the sign, negative or positive. Good? Now, guys, now, very important lecture. Let's see if you understand it. Good? Are you ready? Take a deep breath. Now we're almost there. Look at it. So now I need to understand what is cosine of beta minus alpha. Yes, cosine of beta minus alpha. So, well, it's very simple. It's cosine multiplied by beta minus alpha, yes? So I will take cosine and I will just distribute, like we learned in this distributive law. Cosine distributes through beta and through alpha. And so I get cosine beta minus cosine alpha. If you understood this explanation, please confirm, right? Understood or clear? I explained it, everything's clear now, yes? Come on, very clear, so very clear. Come on, let's see, how many people it's not clear to? Let me just see. Yes, 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 yes. Wonderful. So nice that I know it. I should record this information for future use. For future use. Because you should not agree to nonsense, to stupid things like this, because cosine, my God, as I call it, right? It is a sin. Sin. To imagine that you multiply this expression. It's like what if you say, Arkady, give me a good grade. Do you imagine if you say this, Arkady times, I don't know, Steven, right? What do you think this means? What do you think this means? I multiply Steven? No, it means that I'm going to eat Steven up. You understand? Have you wondered what yes, you see, it means eat. It's in the belly, right? So cosine has eaten the difference of they were just settling their scores, their differences, and cosine ate them, did not multiply them. Do you understand? If you don't, again, you should see my avatar and know what is awaiting you. Do you see the avatar? What do you see there? My probability students had a very good lesson last time, right? I told them what they should expect. I think many of you have not read, and definitely my probability students have not read the story of Little Red Riding Hood well enough? Good? Yes, I will explain the entire thing, but guys, do not multiply. My God, how can you think it's multiplication? How could you possibly think it's multiplication? So let's look back at the original, at my document. You see, so that's what I call, why it's called theoretical mathematics. In theory, you know this material. In practice, you do not. So here is a very simple calculation which you could have made, right? Here is this thing. So cosine of 0 minus 0, right? What is that? It's cosine of 0, which is 1, correct? Cosine of 0 is 1. But what is cosine of 0 minus cosine of 0? That's 1 minus 1, it's 0, right? So you can clearly see it will not be multiplication, right? You cannot distribute it like that. I'm sure no matter how many times I say that, people continue making that mistake. So again, guys, you see, I see that you say yes, no, right? Expect this from me, guys, right? Do your work honestly, nothing happens to you. Do your work dishonestly, I will get very upset, I'll waste my time, I will fail you. I will ask you questions, and the questions will be hard questions, will be theoretical questions. Do you understand what's the geometric interpretation of the derivative? Can you explain how to use that to derive the product rule or the quotient rule or all sorts of things like that? Can you think using calculus? That's a hard question. Then there is a medium question, and then there is there is an easy question at the end, right? And I see how you answer those questions. If you, for example, answer a theoretical question correctly, and I see that in person you don't understand anything, I think you cheated on the exam, and that's bad will. Don't do that. Sorry that I warn you. I just hope to avoid certain situations that happened in the past. So here is the explanation that I will give. Okay, so first of all, guys, do you remember the distance formula? Let's briefly review the distance formula so that we are all on the same page here. So how do you measure the distance between 2 points in a two-dimensional space? So here is one axis, here is another axis, and here is the distance connecting one point, and this point has coordinates A1, B1, and another point here that has coordinates A2, B2, right? How do we measure the distance and why? Okay, so let's see carefully, guys. So what I do is I see hypotenuse of a right triangle, and I complete, I have a horizontal segment and I have a vertical segment, yes? Now, all I have to observe is this will be the square root of the sum of the squares. It's Pythagorean theorem that I'm using here. So what is this? This is absolute value A2 minus A1. And the other side here, it's absolute value B2 minus B1, yes? And my distance is this D. So distance here is equal, distance squared, yes? Distance, careful, Alan, careful. Distance squared equals to A2 minus A1 squared. It's the horizontal side squared plus B2 minus B1 squared. Good? That's my distance squared. So my distance D is the square root of that. Understood? This is the square of the distance. There is I can take the square root and I have it. Do you see how simple it is, guys? It's really the Pythagorean theorem that we're using. Wonderful. So I hope this is clear, guys. So here is how I'm going to use it. Are you ready, guys? And if at some point you don't understand something, please ask me a question right away. So here is an angle beta, and here is an angle alpha, and between them is beta minus alpha, as you can see. So the position of this point is cosine alpha sine alpha. You understand? I make the sides for my trigonometry. I can consider them to be side length 1. So this is cosine alpha sine alpha. Remember the conversion, right? What is the conversion? The cosine alpha sine alpha. This just speaks about the x coordinate and about the y coordinate. It's the same thing. Whenever my unit measurement is the radius. Remember this picture that I drew here, right? It would be cosine just refers to this x, but normalized where it's a proportion of the radius. So what it is really, x over r is cosine, right? And then x is equal to r cosine theta. This tells me that x is equal to whatever measurement of r times the fraction of it, right? The proportion. So this means that this point is cosine alpha sine alpha. Likewise, this point is cosine beta sine beta. Agreed? So then using those points, I see the angle beta minus alpha in between, and I'm going to measure the distance from this point to that point. What is that distance? Let's write it here. What is the distance squared? So c squared, look at it guys, c squared is equal to cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared. In what I have written, is everything clear? So don't just say clear if it's not. Look at it. Do you see what I did? Do you understand why those points are, why this point is cosine alpha sine alpha, this point is cosine beta sine beta? You see, I just took one line at alpha and then I rotated farther to beta, and then I form a triangle connecting them. I'm not claiming it's a right triangle, just a triangle. Yes, the angle in green is beta minus alpha. Is what I want to know, what's cosine of beta minus alpha. Are you with me? Yes, sure. Which part? So you understand what I do? I mean, I want to know cosine of beta minus alpha. So first I observe where I can find the angle beta minus alpha. So I can take angle alpha, and then from angle alpha, I mean, so this angle alpha, and that's the blue segment here, and the red segment is angle beta. Yes? At angle alpha, this point is cosine alpha sine alpha. Is this clear? At angle alpha, the coordinates of this point can be specified in terms of the angle alpha as cosine alpha sine alpha. So make sure that it's clear, guys. This is a very important point here. Conversion from polar coordinates to rectangular coordinates. This is cosine alpha sine alpha. The red point is cosine beta sine beta. Now, the angle between them, I'm not using it here. It's what? It's beta minus alpha. It's the green segment here, beta minus alpha. And then between those points, there is this line segment C. So the length of C is this formula that I wrote here. Clear? Now, what I can do is, without affecting the length C, I can think of it as a rigid triangle. I'm just gonna push it so that it falls flat on the x-axis here. Once it falls flat on the x-axis, this point that used to be cosine alpha sine alpha is now the point 1, 0. Are you with me? This is the point 1, 0. And then what's the coordinate of the other point? Look at it. What happens here is that what remains preserved is that this green angle is coming from the x-axis. So now this point is cosine beta, cosine of beta minus alpha, sine of beta minus alpha. Are you with me? Look at the picture carefully. Do you see it? Here is the angle. It used to be not in the position emanating from the x-axis, and I tipped over this object. Now it lies with one leg on the x-axis, and now this is the angle that's formed here. Yes, somebody was asking.
You're basically using, I guess, like the distance formula between those 2 points
Exactly. I'm using it
Versus-
twice. So I used it once here, and now I'm using it again here. And now the distance formula here, it's because it's still the same length. I just moved the object. The distance remained between them the same. It's rigid motion, right? So this is equal to what? To cosine beta minus alpha minus 1 squared plus sine beta minus alpha squared. Yes, that's what this is equal to. It's a similar formula. So I'm going to erase this. I have this formula below. Do you understand the idea? The idea is, don't memorize any formulas. The idea is that I rotate, I have angle alpha, I rotate, I have angle beta, I formed some triangle. It's not stable, it's balanced at a corner. Now I push it so that it's now stable. It's lying with one of its legs on the x-axis. And now we have the angle beta minus alpha. Clear? If you are interested, I can afterwards, I can show you so many things. I can show you so many connections I can show you the connection to exponential functions and all sorts of other ways to figure out those formulas. So good, understood so far? So here is the calculation simplified. So c squared, from my left calculation, I expand the square, I expand the second square, and look at it. Every time I see cosine squared of the same angle plus sine squared, so cosine squared beta plus sine squared beta, this simplifies to 1. Cosine squared alpha plus sine squared alpha also simplifies to 1. So altogether, blue plus red equals to 2. And then the remaining things, it has a minus 2 in front of it. So I can factor out a minus 2. And I have that c squared equals to 2 minus 2 cosine beta cosine alpha plus sine beta sine alpha. And you understood how I simplify this formula, guys? Come on. We should afterwards in office hours, perhaps I'll give you the control of the board and then you can draw it or tell me what you're thinking. See if you can draw it from scratch, you yourself, not me. You see it? I square it, I get this part. I square it, I get that part. Now I simplify and I put it in this form. Now I can do the same thing with the other formula, which is cosine beta minus alpha minus 1 squared plus sine beta minus alpha squared. I expand it. And again, I have cosine squared and sine squared simplified to 1, and there is an extra 1 here. So I get 2 minus 2 cosine beta minus alpha. Now I have this comparison. I never cared about c squared, but now I have a comparison of cosine beta minus alpha to cosine and sine of the remaining angles. This formula is going to be important, guys, in a moment. So make sure you understand it.
Wait, can you go back to that triangle?
Yes. Okay,
So,
see, guys, so don't try to follow the formulas exactly. Try to derive them on. What is the idea? How am I able to recover it? It just, I understood the idea is that I have alpha, I have beta. So once I open, I'm just rotating this arm. Rotate it to alpha, rotate another arm to beta. So now those two arms at different angles, they form not a right triangle, sorry, they form just a triangle. And between them, the angle is, as you can see, here is beta and here is alpha. The angle in between them in green is beta minus alpha. So I see that I can calculate using cosine and sine of the angle separately. And then if I push this shape, I give it a nudge. So it falls on the positive x-axis. Now the green angle, look at it, because it's a rigid motion. You see, it falls over. And the C stays the same. It's still the same length, just differently oriented. Now the angle is beta minus alpha. This point is 1, 0, and this point is cosine beta minus alpha, sine of beta minus alpha. Good?
Wait, so what was the whole point? Wait, I'm getting confused. So what was the whole point of cosine beta over alpha minus 1 to the second power plus sine to the second beta?
Because I'm going to have an equation. I'm going to have in this equation I will have cosine of beta minus alpha. In this equation I will have cosine and sine having alphas and betas separated.
Okay.
If they are not separated, here they are. You understand? So I have a comparison between both beta and alpha in the belly of the trig function, and when they are not. Here they are not in the belly. Here both beta and alpha in the belly of the trig function. Here Each trig function contains only one of them in the belly. Make sense? Because I want to find a formula, I want to find this. This is what I'm trying to do, guys. So you remember the goal. The goal is to figure out what's cosine of beta minus alpha in terms of cosine alpha, sine alpha, cosine beta, sine beta. That's the point. That's what we're trying to figure out. How is this formula related to other identities of trig? And I will show you afterwards, if you're interested in the office, I can show you how that relates to an exponential and how you can see those formulas using exponentials. If you're interested, I can show you so many really cool things. If you're reading, how many of you have tried reading the quantum physics book that I suggested or watched the video? You watch the video? The video is simple enough, right? So if you're doing that, we can discuss this material. We can read it slowly and we can discuss, if you're interested in quantum physics, we can discuss that. So you have a nice goal in mind. It's easier to learn something when you have a goal, when you're interested in something. Good? So we have then this comparison. Look at it. So we see that this is the formula from doing it on the left, and this is the formula of figuring c squared on the right. And then when I simplify, I can cross away the 2 and divide afterwards. So this 2 and that 2 cross out. Divide by minus 2, I get this formula. Cosine of beta minus alpha equals to cosine beta cosine alpha plus sine beta sine alpha. Here is the formula. Okay. Now I need, now once I have this formula, it's very easy to figure out all the remaining ones, okay? So for example, this formula implies that if I take cosine of pi over 2 minus theta, that will be cosine of the first angle of pi over 2 times cosine theta plus sine, look at it, the minus is a plus sine of this angle, sine of the second angle. And that gives me sine. Now, why is that the case, guys? That's in this picture, you can see it very well. Look at this picture. So this is called a complementary angle. Pi over 2 minus theta is a complementary angle. So let's say sine of theta, it's this side. Yes, they are adding to 90 degrees or to pi over 2. Yes, Alan. Right? So this is sine of theta. Where else do you see sine of theta? You see it also, it's the same length as what you have here. Yeah, same length as what you have here. So sine of this angle will be the same as cosine of that angle. Cosine of that angle is this thing, right? So that's why I would expect this to be true. Are you following me, guys? Have I lost you or not, right? So we derived this formula. Now I know cosine of pi over 2 minus theta will be sine of theta. I knew that from this picture, this formula is just to confirm it. Because the picture is where theta is acute, right? What happens if theta is not acute and whatnot. So that's why I'm not using merely the picture. Are you following me, guys? Some of you look, here is another great word in German, verzweifelt, which means, I can't even remember how you say it in English now, in despair. That's not true, yes? You're not despairing. You understand it so very well, it's very obvious, right? You see, so again, what am I saying, guys? I'm trying to figure out cosine and sine for sum and difference of all angles. And I try to do that fast. So this is the picture why I would expect it to be true. Cosine of pi over 2 minus theta should be sine of theta, because they are complementary angles. And so if I look at this picture, whatever is sine of theta is the same as whatever cosine of pi over 2 minus theta, because for pi over 2 minus theta, this segment is the adjacent. Similarly, cosine of theta should be the same as sine of pi over 2 minus theta, which are the formulas that I have over here. Okay, but here is the verification. All right, so here is using that difference of angles. I just say pi over 2 minus theta, I calculate, and I get sine theta. By the way, what this formula means, it means pi over 2 minus any angle. So if I have sine of pi over 2 minus theta, that means I can take cosine and then plug pi over 2 minus the full angle. Yes? Good? So sine of this angle is cosine of pi over 2 minus that angle, which is, again, when you simplify, it's cosine theta. Those are the identities. We should practice them, guys. If what I'm telling you is not 100% clear, do not go, just stay after class. We can practice it and do it slower. It is a prerequisite for this class. I told you, prerequisite. It is known, right? So you are somehow passing pre-calculus. Maybe you had me as a teacher or something like that, so that I'm not very cruel, that you pass it. But not knowing it means you should not really be in this class. If you're in this class, learn it. So now here is how I can quickly move. Sine of beta plus alpha is cosine of pi over 2 minus beta plus alpha, which I can regroup and write pi over 2 minus beta minus alpha. So now I converted sine of sum of two angles to cosine of difference of two angles, which I know how to implement. It's cosine of the first angle times cosine of the second angle plus sine of the first angle, sine of the second angle. And then I just simplify. Cosine of pi over 2 minus beta is sine beta. Sine of pi over 2 minus beta is cosine beta. Thereby, I obtain sine beta cosine alpha plus cosine beta sine alpha. So it's sine first angle, cosine, and then plus reverse. Okay? I tend to always forget sine, sum of sine, which I then always very quickly derive, so that I get paranoid. You see, I even wrote something here and then I had to correct it. So then once I know that, I can easily figure out what sine of beta minus alpha. It is simply sine of beta plus minus alpha. I know how to do sine of sum of angles. So it's sine of first angle, cosine of second angle, plus cosine of first angle times sine of second angle. And then I replace that cosine of minus alpha is cosine alpha, sine of minus alpha is minus sine alpha. I say so many sine, cosine, I hope you're following, right? I hope your brain is not spacing out. Sine, cosine, tangent, sine, cosine, tangent. You're following me, yes? Here are all the formulas written out for you. Good? Then there is the issue of double angles. If you want to understand how artillery is working, you will need to know these formulas. So cosine of 2 times theta, very simple. It's cosine of theta plus theta, which is cosine of one angle times cosine of the other angle. So that's how I get cosine squared, minus sine of one angle, sine of the other. So we have cosine squared minus sine squared is cosine of 2 theta, which by converting cosine entirely into sine, cosine is, if you remember, cosine is 1 minus sine squared. Yeah, so then I get this other formula, 1 minus 2 sine squared, which is 2 cosine squared minus 1. Good. Similar idea works for sine of 2 theta. We will need those identities for the artillery. We will need to know them well. And then here is the practice, guys. You see, I want you, I'm not going to do it now since I have to move on. I want you to establish the trig identities for tangent of beta plus alpha and tangent of 2 theta in terms of tangent of alpha, tangent beta, type of thing like that, okay? So here's another example of something I might ask if I don't think that you scored your right score on your exam. Okay, so when you do some questions, if you decide that you copy them, I might suspect it. I might not, we'll see what happens, right? But if I suspect it, I will ask you to answer questions in front of me live. In other words, turn on the camera and answer the questions as I watch you, right? So again, learn well. So we don't have that situation. Or don't answer questions that you don't know. Good. So then we have half angle formulas. I will talk about them possibly in office hours if you're interested. Right? There are also immediate consequences of double angle formulas. So that's pretty much all of trigonometry. Let's go back to calculus. All of trigonometry up to this point that you were supposed to know. Let's go back to calculus. Now let's try to find the derivative of sine x. You're going to help me with it, okay? So again, just like for e to the x, I prefer the second notation. Sine of x is sine of x plus h minus sine x over h. That's the definition of the derivative of sine x. Okay, are you ready, guys? We're back to calculus. Take a deep breath. Here we go. So then sine of x plus h, I use the sum of angles formula. That's sine x cosine h plus cosine x sine h. This is the expansion of sine x plus h. It's not sine x plus sine h because it's not multiplication. It happens to be this happens to be the expansion that we derived. That's why I meant why we went through that entire process over there. And okay, so then what? Look at it. I underline here whatever has a sine x, and I group those things together. I can factor out, so I can take this. You understand, guys, how algebraically I go from this line to that line, right? I just break it apart. I have sine x cosine h together with minus sine x divided by h plus cosine x sine h. Here I factor out cosine. Here I factor out sine. And so now here is the $1 million question. What is this? And I'm not asking you for the number, right? I don't want you to tell me 5 or 7 or anything like that. I am asking you, what does it signify? What is it talking about? You understand what I'm saying? So if I ask you what is this, you're not gonna say it's F and I and N and D and I and N and G. You're reading this word, you're taking in the meaning. What is this and what is this? Sinn of the Vaters in German, you say it, die Sünden des Vaters. Well, Christian, you're telling me what it equals to, but I'm interested in what is it. In other words, what is it? What is the description about? When I see cosine h minus 1 over h and I see sine h over h, what is the description about? It's recognition that you need. If you don't answer it quickly, I'll be torturing a cat.
Is it like the same formula, like sine to the second power and that little degree plus cosine is almost the same degree equals 1? Because all of this has to equals 1 anyway because of the formula.
What formula?
Sine squared data plus cosine squared data equals 1.
But we don't have sine squared and cosine squared.
Okay.
We have something else here. Let me try to give you some hints if you don't see it. You see, guys, let's begin with sine h, right? So you recognize this formula. So again, we're having limit as h goes to 0. So what is that? This is sine of 0 plus h. Now sine of 0 is this. It's minus sine of 0. Do you begin to recognize it? Sine of 0 is 0, yes? So that's what I'm seeing in here. Divided by h. What is this? Yes, right? Are you getting me? What is this? I told you guys one major thing in calculus, recognize. recognize that you see the same idea over and over and over again. And when you do, you can harness it. What is this?
So it's something less than 0, right? So isn't it
Not,
like,
it could be less than 0. It could be, well, again, what's less than 0? This full quantity is for small h, it's positive.
okay.
But see, when I say something, I'm not interested in the number. I'm just asking you, what is somebody trying to get here? You understand? Not only, you see, you're reading something, you're wondering, what is somebody trying to find out or trying to say? Not really the solution is as important as what is somebody really trying to get at. It's sometimes more important. Where are we going with it? You know, so the goal is, where are we going with such a formula? Okay, where are we going with this formula? All right, let me help you. Look do you still remember, guys? Do you still remember how we calculated e to the x? You remember that idea? That's what worries me. We spoke about it long, but if I actually asked you to estimate e to the x, or let's say e, or e squared, will you be able to actually figure out what it's roughly equal to and remember this idea? So here is what it looks to me like. This looks to me like somebody was trying to take the derivative of cosine at x equal to 0. You understand? That's what I was getting at. When somebody is trying to take limit as h goes to 0, I'm not trying to calculate or figure out the answer. I'm just saying somebody was trying to figure out the derivative of cosine at 0. That's exactly what this looks like, yes? Here, somebody was trying to figure out the derivative of sine at 0. Do you understand what happened? We began taking the derivative of sine at some arbitrary point x and ended up needing to take the derivative of cosine and sine at 0. You understand? So e to the x, the derivative started at an arbitrary x, and then we had to calculate the derivative at 0. A similar situation is happening here. I really somehow care about 0. 0 becomes important. If I know the derivative of cosine and sine at 0, I know the derivative of sine everywhere. Do you follow? Confirm if you understand what I'm saying. It's very important type of thinking, guys. It's not just because you can look up the derivative of sine anywhere, right? That's not what we're trying to get. In my last lecture, I will show you how you think in physics, for example, right? So you are having formulas, or you have to figure out your own formulas in essence, right? So you have to go through this type of reasoning. Okay. So I will explain in my third lecture that this limit equals to 0 and this limit is equal to 1. I will only say right now just a few small things about it so that maybe you're more convinced. Look at this video. You see this video, guys? Now, look at those numbers. What is, now I press pause. Now theta is 0.23. By the way, for some reason, I was not able to make it produce the third digit. I was able to program it very fast, but I could not figure out how to make the next digit. So I said, oh, screw it, right? And I left it like this. So it doesn't calculate third digit for some reason. But let's say this is correct so far. So what is 0.23 in theta? What does it refer to? What is that? Is it what I drew here, or is it something else? What is that number? Well, angle, sure, but how is it? What is it measuring? What is the? Why is it 0.23? What is that talking about? Come on, guys, don't go crazy just yet. Yes, that's the radian measure, right? So where do you see this this length? It's here. You see, it's here that you see it. It's this segment. So this segment, what this number is saying is this segment is about 23% of the radius, or 0.23 of a radius. Does it make sense? And where do you see sine? Sine is this red rope. Do you see that the numbers are fairly close? 0.23 and this is 0.22. What is it saying? This is saying that this length of this this red leg of a triangle is 22% of the radius. You understand? There is more difference now, right? What is this 0.65? That is this length in radius, right? So this is measured in radians, 0.65, 65% of the radius, whereas this arc is 0.7% of the radius. And there is more difference now, right? Now now I'm actually almost 1 radius long. You see that this length here, it's only slightly more than this length. And this rope is 84% of the radius. You understand? So here when I calculate in this trig limit, look at it. I'm calculating first sine h over h, sine h over h in radians. You understand? H is measured not in degrees, in radians. That's what I'm doing here, right? That's why it will. This limit will be 1. Now, roughly, why would you imagine it to be 1? Look what happens. What happens? They're almost the same. Look at it. 0.39, 0.38. The smaller is the circle, the more the blue arc is like the red line. You see, their lengths are going to be closer and closer matching. You understand? This red leg is almost the same. It's very useful identity, all the time used. Okay, all the time you use it in physics. You use it in approximating time when you talk about pendulum. When you talk about pendulum, you use it in so many applications. Good. Even here, let me so. Calculus in nature. This lecture I will probably mostly skip because of time. And here is, let's say, capstan. I'm explaining why pulling a motorcycle directly is much harder to do than if you wrap the rope around a tree trunk. All right. And this is where I use, you see those pictures? That's where I use approximations like this. You see, I have sine of delta over 2. So this is just from the physics book that I suggested you read. And I carried out those calculations. Okay. I carried out, we're only going to cover, I suppose, from trigonometric limits where I explain precisely why that is the case. But here is a question in physics, and here is, I mean, there is the question is explain why wrapping a rope around a tree trunk makes it easier to stop a motorcycle than if you are trying to do it directly like this. You see what I'm talking about? This is a question that you have, and then you have to come up with your own formulas. That's what you are trying to develop in your reasoning. Good. So roughly speaking, it's going to be, when I say sine of h over h is going to be 1, that's because I'm thinking that the red line and the arc, this is the bottom is the arc, they are almost the same length. By the way, if h is positive, if I rotate the arc counterclockwise, tell me please, is this quantity, is it bigger than 1 or smaller than 1? Less, right? Because the red, this means the red, or the vertical red segment, and this means this here means the arc. The arc is longer than the vertical segment, always. Yes, so you're expecting this quantity to be slightly less than 1, but approaching 1 as h goes to 0. With me? So you stopped responding, right? It's like you are already at the top of the mountain and you cannot breathe anymore, right? You're already lying there. What is it? What do you call it? Like in that poem, and call it death or cowardice. Don't count again on me. You know the song, right? There is a hammer at my knee. So what about cosine? Yeah, no worries. You can have time to process, but stay with me, guys. Right? After class, we can discuss it at greater length. It's all review. See, in theory, it's a review. I'm not sure what you learned in your previous classes. So here again, guys, in this picture, it's a bit harder to give an intuitive explanation for this, right? For cosine. But do you see this segment, guys? This segment over here. This is 1 minus cosine h. Yes, so this segment is going to 0, right? It's going to 0 much faster than this arc is going to 0. So this divided by h will go to 0. We are going to explain it formally, but I'm trying to illustrate why you might expect this to be true. Okay, so if this arc is going to be smaller, this is going to be, you see, you have like this type of triangle here. This arc is staying. It's staying essentially. This is going to 0, and this arc is like essentially like this vertical segment. Okay, so 1 minus cosine h over h will go to 0, and therefore cosine h minus 1 over h will go to 0. By the way, cosine of h minus 1 over h, positive or negative quantity if the angle is positive? Cosine of h minus 1, positive or negative? Comments? Negative, exactly, it's negative. Guys, again, right, if it's hard, don't be disheartened. And don't shy away from it. You understand it once, it will stay with you forever. All right, so here is the conclusion that we hopefully have obtained. I'm not sure if you're convinced by now, but this is the conclusion, guys. If I, for a moment, forget about the fact that I do not exactly know what this limit is, I just have I have an idea this will be 0 and this will be 1. Then I know that the derivative of sine x is cosine x, because this is 0 and this is 1, so the derivative of sine x is cosine x. Notice this is only true if I measure the angle in radians, not in degrees, because this limit is, you see, if h is measured in degrees, this limit is not approaching 1. I'm saying the length of the red line compared to the length of the arc is almost 1, not the degrees, you understand? Not the number of slices. So this limit is not equal to 1. By the way, an interesting question is, of course, can you find the derivative of sine x degrees? Right? Derivative of sine is cosine, but only when I measure it in radians. What about derivative? So this is the question. Maybe I'll ask that question as a hard question, right? So it's not really hard, but derivative of sine of x degrees, what is that? Good. So we'll get there maybe later. Okay. So here is what we get. Derivative of sine is cosine. You should try to show the derivative of cosine is minus sine. You see, how do you begin such a proof? You just expand cosine. So you have cosine of x plus h minus cosine x over h. And the expansion of cosine is what? This thing you can write as cosine x cosine h minus sine x sine h, right? This is here, right? And then you expand it and you do the same thing for what we did for sine. Good. So now you should breathe a little easier. We are going to now, assuming that we know derivative of cosine is minus sine, derivative of sine is cosine, we are going to solve a few very simple exercises, okay? So like you love simple find basic derivatives, very easy questions. Okay, so here is, guys, what I want you to do. You can, using the knowledge that the derivative of cosine x is minus sine x, and the derivative of sine x is cosine x. I would like you to please tell me what is the derivative using this. What's the derivative of tangent x? So all the hard work is finding the derivative of sine and cosine. Finding the derivative of tangent is very simple. Let me give you a hint. It's because a tangent can be written in terms of the previous trig functions. It's really like the derivative of sine x divided by cosine x. That's why it's so simple. Funny, by the way, here you see just received, did I tell you to read Erich Maria Remarque? Did I tell you about him?
Wait, I got a question. Wouldn't it be kind of longer than that?
I didn't say what Alan said is correct. So guys, so I see that Mustafa and Brandon and a bunch of you, what you did is you took derivative of numerator and divided by derivative of denominator. That's not how derivatives work, my friends. Remember that. Remember what it is. This is a quotient rule, which you are supposed to prove. And how does quotient rule work? Do you remember? If I have a familiar function f divided by g, and I take its derivative, what do? I square the bottom function, I copy the bottom function, multiply by derivative of top, minus roles reversed. Yeah? And that's the formula for the quotient rule, which, by the way, using the geometric approach or other approaches, you should verify. Not just because you could look or not look it up. It's because if you understand what you're dealing with, you are familiar with them like friends. Otherwise, they're your enemy. Okay, that now is better, Muhammad. And better to say just something else, simplify it. I mean, it has a name. Well, you will see in a moment if you don't see what I'm talking about now. Come on, guys, faster. Yes, Carolina, secant is 1 over cosine. All right, let's do it together. I want to solve a few more questions before we are done. Yes. Yes, Rachel. So here is how we do it. I square the denominator. You see, main operation is division. So cosine squared, I square the denominator. I copy the denominator without bothering it, multiply by derivative of sine, minus, reverse the roles. So it's now the derivative of cosine times sine x. Now you see it, yes? I'm going to erase the top line so that I can still write here. Now what is this? I get, this is cosine times cosine, so this is cosine squared. Derivative of cosine is minus sine, and there is another minus here. Do you see that? I get plus sine squared x. You see how I did it, guys? Because derivative of cosine, let me write it in blue. This guy has derivative minus sine x, so there is an extra minus. So minus minus, it gets, I have now sine squared plus cosine squared, which it's much more polite to call 1. So the answer is 1 over cosine squared, or simply secant squared, because secant is 1 over cosine. Good? Now help me figure out the next one. Tell me what is the derivative of secant x. Yes, that's what I meant by name, Muhammad. I meant it's a secant. Derivative of, you said correctly, it's 1 over cosine squared, but it's like 1 over cosine squared. 1 over cosine is secant. So now take the derivative of secant, please, and do it fast, guys. Lesson is almost over. I would like to finish this and a few more examples. Three people escaped, I see, when I was not looking. So guys, how do you do it? Very simple. It should take you 2 seconds. This is the derivative of 1 over cosine x. Okay, so simplify this thing. Carolina, secant tangent. Yes, good, Carolina. Oh, good. So how do I do this derivative? More of you should participate here, guys. Yes, Muhammad, and simplify it. So the derivative here is, again, we use quotient rule. So we square the denominator, copy the denominator, times the derivative of 1 minus derivative of denominator multiplied by 1. Now derivative of 1 is 0. Yes, derivative of 0. So what we have is simply derivative of cosine is minus sine, and there is an extra negative. So what we have is sine x divided by cosine squared x. And this is 1 over cosine x times sine x divided by cosine x, which is secant x times tangent x. It rhymes better. So derivative of secant is secant tangent, right? So it's, yes, good. It's secant tangent. So let's do one more. Tell me what is the derivative of cosecant x. Remember, cosecant, it's just to remind you, this is simply the derivative of 1 over sine x. Please calculate it very fast. So Carolina, sinus is not exactly, it is the same function when you view in different coordinates, right? It's different a little bit, right? Sinus, cosine refers to the horizontal leg, sinus refers to the vertical leg. Come on, you can do it. Okay, Christian, let's see, what is it? So Brandon, it's 1 over, so careful guys. So that's correct yourself here. So if I see some, Mustafa, you didn't square the denominator. The same, yes, so good. Guys, this is just a basic, you see, you need to know quotient rule, not just remember it, hopefully you know it. What do? You square the denominator, copy the denominator, multiply by the derivative of 1 minus, they are reversed now. Now the derivative of sine times 1, which is, derivative of 1 is 0, so what we have, and the derivative of sine is cosine, so it's minus cosine x divided by sine squared x, which if I factor it, I can write as minus 1 over sine x multiplied by cosine x sine x, yes, which is minus cosecant x cotangent x. Okay, so we're about to end today's lecture. Just one thing that I was reminded by, you know, I often write the word remark, and whenever I do, it triggers this association. It triggers the association Erich Maria remark. You know why I mentioned it just now? Actually, I just received a text message from a student that used to be my student back in 2012. She even invited me to her wedding. So I told her, I introduced her to this author. He is very good. So you might know him from All Quiet on the Western Front, but his best work, in my opinion, there are 2 of them, right? It's 3 Comrades. Or in German, it's drei Kameraden. Okay, very good book. Is not very known in Germany. So that's just, yes, drei Kameraden. I read it a long time ago in Russian. Later, I read it in German by now 2 or 3 times. 2 times for sure. And I read another book by him, and actually I read another 3 books. So this one she became obsessed. So she found his first book, and she sent it to me. So anyhow, so that's just regarding reading and literature. I hope you try it. Interestingly enough, most Germans do not know him or know him very poorly. Every German I've ever spoken to, they don't know this author very well, even though he is German. So guys, so here, before you leave, one last comment, okay? So we can do so many things right now. If you want, we can do more exercises where we take derivatives of different trig functions, so you prepare for onwards, right? We can practice trig identities. We can do the ballistic. We can talk about quantum mechanics if you consider the beginning of it, right? We can have so many interesting things to discuss. I can show you, I might show it eventually, maybe we'll see, right? How this trigonometry relates to exponential functions. And that you need to know if you are reading this book on quantum mechanics. It's possible to get through it. At least I've seen the first 60 pages. So far, it's not too bad. The only thing is if you know mathematics, it's better than if you don't, because you would do it another way. Like I read this book, I see how he's doing it, and I like to do it another way. Anyhow, so if you're not staying, guys, have a good day, have a good weekend, and yes, take care. If you are staying, we can do artillery, we can do so many wonderful things. What is GN? It's good night. Wonderful. Take care, Zoheb.